Hello, and welcome to the Biomass Magazine podcast. I am your host, Anna Simmet. Thanks for tuning in. On this episode, I have with me Bob Petrachko, Senior Process Safety Consultant at Dustcon Solutions. Bob, how are you? Welcome. Thanks for coming on the podcast.
Fine, thank you, and thanks for asking me on.
Absolutely. So, I think to begin today, Bob, why don't you tell us about Dustcon Solutions and what it is that you do there?
Okay, certainly. Well, we are a process safety engineering consultant firm, and we help clients manage process safety hazards through a variety of services like dust testing, dust hazard analysis, hazardous area classification studies, and process hazard analyses. Our main goal is to provide clear and actionable guidance that's easily understood and implemented. The implemented may not be so easily, but that's our goal. Personally, I've been with DustCon for over 4 years as a senior consultant, focused primarily on dust hazard analysis and hazardous area classification studies. I'm a member of the NFPA 61 Technical Committee, and before starting with DustCon, worked as a plant engineer on the receiving end of dust hazard analyses, so I can relate to our clients pretty well, I think.
Mm-hmm. So, aligning with the theme of the next issue of Pellet Mill Magazine, which is fire and explosion protection, our chat today, we're going to focus a lot on DHAs. So, let's just go back to the basics. Can you explain what a DHA is and what they serve to do?
Certainly. So, the intent of a DHA is to identify combustible dust, fire, and explosion hazards related to the process facility, then identify and document the existing safeguards already in place and recommend additional safeguards that are missing. Safeguards would include things like explosion and fire mitigation, but also management systems elements are an integral part of preserving safety. The DHA document that we delivered then also should become an important reference for management of change reviews going forward after that.
So, Bob, you presented at our biomass show back in March, and you shared a lot of information based on that firsthand experience you get on actual visits to 15 wood pellet plants that you went to in 2023, large and small, from Northwest Canada to the Deep South. And, you found some areas wanting in DHAs, which is the purpose, obviously. So, can you tell us about some of the most common things that you found and then ways to address them?
Be happy to. I'll preface my findings by first saying that NFPA 664, the Fire and Explosion Prevention Standard for wood processing and woodworking facilities, does not provide all the direction you need to protect the drying systems. So I really try to understand the process as much as possible when on site and afterwards. And I can also say that the Wood Pellet Association of Canada, WPAC, is an excellent online resource for safety reference as well. So starting with the front end of the process, rotary drum dryers are complicated. They can't be directly explosion protected because you can't hang a device off of a rotating drum. So the focus has to be predominantly on ignition prevention. So you have spark detection and extinguishment between the dryer and the inlet to cyclones. That's required, that's common, that's what you see all the time. What you don't see all the time is the explosion venting needs on the cyclones that the dry fiber is being blown into to prevent propagation back into the dryer. What's even less common than that is the explosion isolation on both ends of the cyclone. You need a whole package there to prevent propagation of an explosion back into the dryer, since, as I just said, you can't really protect the dryer itself other than trying to close it off from the external ignition sources. Now, in addition to combustible wood fiber, which we just talked about, you also have a big risk from combustible gas, which typically is considered a syngas. So what's standard procedure is you have to ensure you have good furnace controls in place and that they're regularly tested. But you also have to ensure that timely cleaning takes place to prevent the buildup inside the dryer, because buildup in the dryer itself and in the ductwork downstream of the dryer can get to a point where that syngas is not purged effectively and then could cause the problem that we're just trying to prevent. The part about timely cleaning also goes along to ask the question, can air recycle ratio impact syngas concentration? And that's we don't know the answer to that one way or the other, but potentially you can see how it might. Recycle ratio gets too high, the syngas concentration could. So all those things have to be assessed somehow. Now, a strong management change procedure is critically important in all this, because a change in fiber composition, for example, can affect the cleaning frequency, because some species of wood build up more resin coating than others, and it has to be taken into account. So those are the highlights for rotary drum dryers. Fiber composition changes can also affect other parts of the operation as well. So again, a strong management change procedure is equally important for anticipating the impact of those changes. For example, your next door sawmill supplier of sawdust goes down, and now you have to bring in a mix of whatever you can find. And this can greatly increase the fiber's abrasive characteristics, leading to quicker wear of equipment, conveyors, and increase the housekeeping problem. Also, some species are more dusty than others, thereby enhancing the deflagration hazard. So fiber composition needs to be taken into close consideration and become part of a strong MOC to make sure that you've thought ahead and are prepared for what negative changes might take place. Rounding out the discussion on dryers, let's talk about belt dryers for a moment. Belt dryers have different problems than rotary drum dryers. The longer residence time of fiber in the dryer can allow burning embers to grow and to initiate a fire. So what's commonly in place is water spray deluge activated by spark, flame, and or heat detectors. But there have been explosions in the belt dryers also. And I haven't seen explosion protection on these dryers, but it needs to be considered. Moving from drying, let's talk about dry conveyors for a minute. Dry conveyors overall are well protected with explosion vents, and they need to be. But what's not so commonly paid attention to are the flameless vents that are found indoors, usually milling and pelleting operations on the infeed and outfeed conveyors. They need to be covered. They need to be covered to protect the buildup of dust that accumulates in the mesh. And those covers need to be inspected to make sure that they're always covering all of the mesh. This dust buildup on the mesh, believe it or not, can be ignited if an explosion event were to occur, and afterwards, or in the process, initiate a secondary explosion, which in effect negates the whole reason for flameless venting in the first place. So that's an easy fix, but it's one not thought about and easily overlooked. So I recommend paying close attention to that. Dust control fans, a great help to the housekeeping issues on the indoor operations, but they need to be well positioned and regularly inspected for maximum effectiveness. Dead zones that are out of the reach of the fan can allow for large amounts of fugitive dust accumulations on top of the infeed conveyors, for example. But another one that's particularly concerning is knowing where your high dust generating areas are. In these areas, fans need to be interlocked to run when operations restarts after a maintenance shutdown, for example, after maintenance. Otherwise, this can create a dangerous situation by raising an explosive dust cloud. Electrical rooms is another area. They're not always pressurized, and they should be. But if they're not, very strict and frequent cleaning procedures need to be followed to clean the dust incursion from the hard-to-reach recesses in the electric room panels. There have been explosions resulting from this. Lastly, I want to come to the end of the process and talk about pellet storage silos for a minute. They're a well-known fire risk from self-heating, and most owner-operators focus on minimizing the turnover time and they rely on temperature and CO monitoring and alarms to initiate dumping if needed. But sometimes a situation can still get away from you. So the site needs to ensure they have a well-defined emergency response program prepared in collaboration with the local fire department, who's going to help them out if they get into big trouble. Beyond this, there are also some other situations that deserve special consideration of additional engineered standards, such as nitrogen purge and fire extinguishing foam, particularly if you have a situation in which you have maybe just one storage silo, one large storage silo, and the railroad schedule is impacted and the cars don't show up on time. And now you've got an excessive amount of time with a loaded silo that's starting to get hot on you. So that all needs to be taken into consideration in deciding your safeguards. So that's a summary, the overall summary of what I have to say about DHAs in pellet mill plants.
Really great, thorough answer, Bob. Thank you so much. So, how often should a pellet plant have a DHA performed?
NFPA 664 refers to NFPA 652, which says a DHA shall be completed for all existing and new processes and shall be reviewed and updated at least every 5 years. Now, for example, may be done in less than 5 years if significant changes have been made to the process, in which time you then restart the 5-year clock from there. We also do DHAs for projects in the engineering design phase. That's the best time of all to do it.
All right. So, another question I have is regarding plant safety and hazards. How can operators help ensure their personnel know what to look for and when to act?
First, training is number one essential. It should include all the basics of combustible dust safety, and the owner operator should add in enough pictures to describe the hazards and mitigations that the operators will see in their day-to-day work. The mitigations should include the personnel's responsibilities, for example, such as their responsibilities to housekeeping, so they fully understand the importance of what they're being asked to do. These responsibilities then should be well documented in their SOPs. There should be annual refresher training until this becomes a solid part of the plant culture. Secondly, not to be overlooked, contractors should also be trained for the specific areas they'll be working in while on site, and especially if they're going to be involved in hot work.
Okay. And then my final question is, what's a hazardous area classification study and how does it complement a DHA?
Okay, thank you. Well, a hazardous area classification study, if you don't mind, I'm just going to call it by its abbreviated form of HAC, HAC. Should have been
It's
doing
easier.
that. Well, first, there's a big overlap between the two, as both are heavily impacted by the state of housekeeping. The purpose of the HAC is to identify the three-dimensional physical boundaries within which it's possible to, under normal or abnormal conditions, for an explosive concentration of dust to occur. Now, if this dust is occurring normally, that would be classified as Division 1 or Zone 20 or 21. If that concentration occurs abnormally, it would be classified as a Division 2 or Zone 22. We want to stay away from Div 1. Okay. Now, this study is done by locating on a plant walkthrough, point sources such as valves that can leak if not maintained. And it's done for the purpose of specifying electrical enclosures and equipment so they cannot be an ignition source. Poor housekeeping makes this a bigger problem because it is the availability of fuel, for example, the explosive dust concentrations that present the hazard. Broad area covered by layers of dust is susceptible to dispersion, for example, by compressed air cleaning or natural air currents, and is hazardous for that reason. So though the focus of a HAC is to prevent electrical discharges from becoming the ignition source of an explosion, a hazardous area must be minimized in size because other ignition sources are still available. Upgrading electrical equipment can be expensive, and so recommendations are made in the HAC and in the DHA both on how to reduce the size of the hazardous area through housekeeping improvements. But the deliverables of the HAC study are plan and elevation drawings with the hazardous areas crosshatched. Electrical enclosures inside those areas must at least be dust tight. This also allows the option of moving electrical ignition sources outside of the crosshatch area. Inside the area, motors also have to be specified so that a maximum temperature reached from its own heat generation cannot ignite a layer fire from dust buildup on its surface. And just like a DHA, we also prepare hacks for projects in the engineering design phase. But in conclusion on the subject of hacks, I have to say that they can be as much impact by changes as a DHA and should also be updated on a regular basis through management change review and DHA updates.
Okay, great explanation. All right, Bob, we're closing in on time to wrap up. But before we do, is there anything else that you want to add?
I've tried to put it all in what I've just said to you. So I can't think of anything else but to say that again, I'll put in a plug for DustCon. That's what I work for. I love what I do. Very anxious to help people. I look at these issues from the client's perspective. Try to think through it as much as possible to minimize the impact, but not take any chances about crossing the line on safety. Personnel safety is number one, and that's what we're all about.
Absolutely. Thank you so much for coming on and chatting with us about DHAs and the things that you've seen when visiting pellet plants. It's extremely valuable information to share with our plant operators in the industry. It's very important work. So thank you so much for that.
Thank you, and I'm available and glad to help with any questions anyone might have.
All right. And thanks to our listeners. Thank you so much for tuning in. I hope you enjoyed this episode. Until next time.